Hey guys, welcome back! We're so excited to share with you how we built this fabulous 4-story mansion just in time for Marmaduke's 1-year birthday. First, if you haven't already seen it, please click on this video to get an overview of the new tank, showing all the major upgrades we've made since the previous terrarium. It also includes Marmaduke chasing superworms around the tank, which is pretty fun to watch. So, as I mentioned in the previous video, we wanted to show you all the details about how we actually built this tank. So I've made this next 2-part video series to show you exactly how we put this in together with all the technical details. And oh my god, you guys, I had over 8 hours of video from 2 different cameras that I've edited down to make these videos. It's actually taken me an embarrassing amount of time to put these videos together. Like, I'm talking weeks of editing. So I hope you enjoy. And please forgive me if some parts are a little shaky. One of the cameras obviously sucks a little bit more than the other. So in this part 1, I'll show you how we designed and built the structure of the vertical tank addition that sits atop and straddles the old tank on the bottom, including the internal components for heaters and lighting. In part 2, which I will link to at the end of this video, we'll cover the design and construction of the interior landscaping components. So stay tuned for that one as well. Alright, let's get to it. With our vertical addition, we wanted to still keep the existing tank at the bottom. After all, we really loved those gratted tiles, so we think they look great and they're so easy to clean. And a lot of work had already gone into making it with the background and all, so we wanted to keep and reuse as much of it as possible. So in order to expand this tank in the vertical direction, we basically needed to come up with a design for a tank structure that would sit on top of and sort of straddle the existing tank. The original tank is 17 inches high, and with the addition, we would add another 25 inches of tank space, with a top 10-inch compartment for lights. Here's what the frame of the tank addition looks like with a bit more detail. You can see here that the idea is that it would sit on top of the existing tank to add vertical height. So in terms of volume, the original tank volume was about 48 gallons, and the new volume added is 70 gallons. So between the two, the total volume of the new tank would be nearly 120 gallons. That's a lot of space for a bearded dragon to play. The construction of the new frame is based around cutting and welding together long pieces of angle aluminum to build the structure. The aluminum we chose to use has a 90-degree right angle in the corner, with each side of the angle being 1 inch in length. The thickness of this aluminum is 1/8 of an inch, which, along with that right angle corner, is very sturdy for structural applications. We also wanted to build a hidden light compartment up at the top to hide the lights from view, but mostly just to get them out of the way so they wouldn't need to be moved around in order to get access inside the tank. The sides of the upper light compartment are sealed off with black chloroplast, which is basically a corrugated plastic material, similar to how cardboard is made, but with plastic instead of paper. As for the front of the tank, we wanted to include a mesh door, so we decided to divide up the front face of the tank with a piece of angle iron down the middle. On both sides of the tank, as well as the left half of the front, we would install 8-inch thick, UV resistant acrylic plexiglass. And on the right half of the front, we would construct a hinged door made of mesh that swings out to the side. So we were happy with this general design and the additional amount of space it would give Marmaduke to play. But then we realized a slight issue. In order to get the tank addition to slide down on top of the existing tank, you have to have enough space above the tank to lift the entire addition above it to get the legs over the top. But of course we have a ceiling in our house, and since this tank almost goes up to the ceiling actually blocks us from being able to lift the tank high enough to do that. Whoops. So we came up with this idea. First, we would add another strip of angle aluminum to connect the legs on each side of the tank. That would add some more structural stability to the whole system. Then, near the end of the build, we'd actually cut those legs off at the height of the original tank. I know it sounds weird, stay with me. Cutting the legs off allows us to simply slide the addition back on top of the existing tank, rather than needing to lift it from high above with the legs still attached. And this solves the issue with the ceiling being in the way. Hooray! But of course we do need to use those legs, since we don't want the entire weight of the top addition sitting directly on the lower tank. So we'd take those legs that we had cut off and attach them back to the tank, kind of around the bottom, and then install some bolts through the legs into the upper frame to connect it all together. Alright, with that pre-planning out of the way, let's get to the build itself. We can separate this out into several distinct parts that needed to be built separately and then welded together. You can see here that there are basically 3 identical rectangular frames that would be supported by the legs of the tank. So we just started the build with these rectangular frames. First, we purchased some long pieces of angle aluminum and cut them down to size by securing them in a vise and using a portable bandsaw. Because we wanted to join 4 pieces together to form the 4 edges of each rectangle, the corner of these pieces were also cut at a 45-degree miter angle. The cuts weren't perfect straight off the bandsaw, so we took them to the belt grinder to get the edges to line up properly. To assemble the rectangle, all 4 pieces had to be meticulously clamped to the welding table, then checked and rechecked to make sure the pieces lined up and formed perfect rectangles. It's really important that the corners of each piece are all square. All the clamps and brackets we've used just made sure that the aluminum doesn't move or warp due to high heat while it's being TIG welded. And here's Marmaduke stopping by to remind us of the importance of wearing a welding helmet, because safety first. Small tack welds were made in each corner just to make sure everything was in the right position. Then a full bead was laid down to fully join each corner. And in order to make sure that this rectangular frame would fit nicely inside the legs of the tank, we rounded out the corners on the belt grinder. You can see here that the frame fits snugly into this other piece of angle aluminum now. So then, of course, the whole procedure had to be replicated to make those 3 identical rectangular frames. By stacking them on top of each other here, you could see that they were indeed nearly identical in size and shape. Alright, so the 3 rectangles are done. Now, 4 legs of the tank need to be attached. This is going to be a bit tricky since everything needed to be completely level in order to keep the tank stable. So how are we going to clamp this together? Basically, we decided to flip the tank over and assemble it from the top down. That would allow us to clamp the first rectangle to the welding table and attach the legs while they're sticking up in the air. Here's the first rectangle being clamped to the table and the first leg being attached. Here you can also see the rounded edges we made with that belt grinder, which allows the leg to fit snugly over the corner of the rectangular frame. Then we measured the angle of the leg to make sure it's level with the table, and used some other pieces of angle aluminum clamped into this pyramid structure, just in order to keep that leg from moving at all while being welded. And this pyramid structure is just temporary for support and will be removed later. The leg joints were then welded to the rectangular frame on both the outside and the inside. Here's what it looks like a little further along with all 4 legs now in place. Then we could slide the second rectangular frame down and then weld it together. Then we removed all the clamps and support beams so we could turn it upright and take a look. Looking good. And this is after welding on the third and final rectangle. Another feature we wanted to incorporate into the frame was some brackets to hold up the lights inside the upper compartment. Now the lights could be placed directly on that screen, but we preferred to put them on brackets to lift them a bit higher and sort of block them from view. Remember that this thing is going all the way up to the ceiling, and the lights way up at the top will be facing down at us. So concealing those lights a little higher up in the compartment would prevent us from being basically blinded by the lights all the time. So we built these 2 brackets that would attach to the frame inside the light compartment and give the light fixtures something to sit on. And it sure took a lot of clamps to hold together all the little pieces for these brackets. This is how the light fixtures would sit on these brackets. And here's where they were welded to the inside of the frame. We also welded together an aluminum frame for the front mesh door, along with some hinge hardware and a latch to hold that door closed. There were a few more internal elements needing to be fabricated from metal. First, this shows you how we were planning to create usable vertical space by mounting these 3 staggered shelves up the sides of the tank, with some sort of tree-like climbing structure up the middle. We were planning to put a ceramic heat emitter and dome up inside the light compartment, and this would keep the top shelf and upper area warm. However, that doesn't do much to heat the rest of the nearly 120-gallon volume. So we knew we needed to add some other heat emitters throughout the space. Now, it would be totally unsafe to just put heat emitters anywhere, because Marmaduke could climb onto them and possibly burn himself. So we needed to construct some sort of barrier around those heat sources. We then planned to mount those 2 protected heaters to the undersides of the lower and middle shelves. That would keep them tucked out of the way and also make sure heat is being delivered to all areas of the tank. So first, let's show you how those shelves were made. First, we had to seal off the back panel of the tank before we could mount any shelves to it, so we decided to do that with 1/2-inch construction grade plywood. We planned to screw this plywood directly to the back aluminum frame, so a bunch of holes had to be drilled in the aluminum. Then, corresponding pilot holes were drilled into the plywood panel. Then this panel could simply be screwed into place when we got a little further into the project. Now, onto those shelves. So I want to show you this drawing I made that was basically the design concept. I know to this point I've been just showing you those fancy computer animations, but honestly, this whole concept started with this simple drawing. The shelves were the first design element of the build rather than a structural element, so I busted out this pencil drawing to help guide exactly how I wanted to make those shelves. I know this drawing is a little bit cluttered, so here are the 3 shelves in the drawing. Using the drawing as a guide for how I wanted the items to be arranged in the tank, I was able to freeform draw out the shape of each shelf onto a piece of plywood. This here is the middle shelf, which I knew I wanted to include a log-shaped hide for Marmaduke. So I drew out this shelf to include a wide back portion to accommodate the log. And here's the drawing next to the lower and middle shelves. We marked X's on the plywood to help remind us which side of the curve we would be discarding. Now we don't have a jigsaw to cut this, which would have made it so much easier. So we had to use a skill saw instead, which is actually much more difficult to control and get into these sharp curves like these. So we used a hole bit on the drill press to remove material from these narrow curves that were difficult to get the saw into. Then we filed off the sharp, splintery edges. Time for a test fit. The lower shelf would sit directly on the lower rim of the frame. The middle shelf would need a bracket to attach it both to the back panel and to the front corner of the frame. Same goes for the top shelf. We used some clamps to temporarily hold the shelves in the desired location. Here's a test fit with the back panel and all 3 shelves in place. You can see that we've also cut a plywood panel for the back of the hidden light compartment, with holes for ventilation at the top, and another at the bottom to pull cords through for the lights and heaters. We also, at some point during this process, had welded together that hinged door frame for the right side of the tank. And here's Marmaduke checking in for quality control, just making sure that the shelves meet his very tight specifications. Okay, so remember how we wanted the heat boxes to sit underneath these shelves? Well, we wanted to make the best use possible of these heat sources. So instead of the heat simply dissipating out into the air in the tank, we wanted that heat to be absorbed by the shelves in order to keep the temperature more steady. In theory, the addition of these so-called heat sinks would also mean we wouldn't have to use as much electricity to keep the space warm, since the materials inside the tank would retain heat for longer periods of time, and air convection around the shelves would help circulate that warm air around the tank. Well, we thought thick plates of aluminum will retain a lot of heat, so we came up with the idea to cut some aluminum plates to the approximate shape of the shelves, and then mount them directly to the bottom of the shelves. We also wanted to increase the surface area of these heatsink plates so that they would absorb even more heat, and so that they would facilitate airflow around the shelves. So we welded a bunch of parallel aluminum fins to the bottom of each plate. Then, these heavy aluminum heat sinks were screwed into the bottom of each shelf. And to get even more heat transfer, some aluminum rods were welded to the plates and then poked up through holes drilled into the plywood shelves. I know this looks pretty weird for the time being, but eventually those rods would be bent over and covered up, and with these aluminum rods making direct contact between the heatsink and the shelf itself, that would help keep the whole surface warm. And if you want to see more about that, you can tune into part 2 of this video series. Okay, with the shelves out of the way, now it's time to build the boxes to protect the heat emitters. Remember that we're planning to mount these underneath the lower and middle shelves. One thing I didn't mention earlier, but we wanted to avoid having sharp corners like this sticking out in the tank area. So our first idea of making a simple cubic structure wasn't quite right. We'd need to make a slightly more complicated polygon shape to surround the heater and have more sloping corners at the bottom so no one would poke their eye out on it. So this is what we ended up making. It's basically an irregular hexagon shape with 6 sides in order to create a more rounded shape around the heater. The bottom panels have also been bent inward to give a more gentle slope and avoid those sharp corners at the bottom. And of course this is the final product here, so let me show you how we made these heat boxes. Initially, I had made out a few sketches to test out different designs, then I transferred the best design onto a full-scale piece of poster paper, including also a top view of the heat box with the angles of each bend. Then we used that to build a more sturdy intermediate model out of cardboard. Once we were quite sure that this design would work, the pattern was copied onto a 22mm sheet of mild steel. We've also covered the steel in a blue marker so that our lines are easier to see. All of the planned bend lines were marked onto the metal surface with a carbide scribe tool. And just like we did with the shelves, to make it easier to get a saw blade into these sharp corners here, we used a drill press to cut out small holes in the metal of each corner. Okay, ready to cut the sheet. So we mounted the bandsaw back to the cutting table, then made cuts in the sheet from the outside edge down into those little holes that we had drilled. See how that hole makes it easier to get the blade into the desired location without getting stuck? And then the unwanted pieces pop right out. These angled cuts here are to cut the folded panels at the bottom of the heat box. There's also a little tab there so that when it's folded together, each tab overlaps the adjacent panel and makes it easier to weld together. So we were kind of limited by the size of the cutting table, so in some places, especially these really tight corners, we weren't able to get the saw blade in all the way. These spots were also difficult to get out with handheld cutting tools. So to remove this little segment above the tabs, we decided to just brute force it and drill out the cut lines with a drill press. Back in and pulled out the cut pieces with pliers and filed down all those sharp edges with a hand file. This was a bit cumbersome, but it worked. While we're doing all this hard work, Marmaduke is chilling in his warm, rock-filled outdoor enclosure, taking a little snooze underneath a toasty rock. Okay, back to the heat boxes. At this point, all the edges had been cut, so we wiped off the blue marker and used a handheld disc grinder to make these shallow grooves along the inside of the fold lines. This would just make sure that it folds up more easily and right at the intended place. Kind of like those perforations on sheets of paper that allow you to tear it cleanly. To bend this sheet metal into the desired shape, we hung it over the edge of the table and clamped it to the table with this piece of straight steel along the fold line. To push the overhanging panel into place, another piece of steel was clamped underneath. Then, referring to our drawings, and using this handy magnetic angle finder, we bent the panel up to the designated angle. After each panel was bent, the clamps were removed and the sheet was shifted down to the next panel and reclamped into place. Then we just repeated this all the way around until the whole sheet was bent into shape. Now it's time to fold the lower flaps inward. We had to cut out a little piece right here so that the corner would bend without overlapping. And those little tabs that we had cut out earlier also needed to be folded up. Then these panels could simply be bent into place until they all touched in the center. Remember, earlier we had cut those shallow grooves on the inside of the sheet to guide these folds. And drilling out those small holes in the corner also makes room for the panels to line up nicely. Cool, now it's ready to weld. A clamp was used to hold each tab in place on the top of the adjacent panel, and a tack weld was put in place to secure the panels together. After that, all the join seams were fully welded together. And after that, the whole procedure was repeated a second time to make another identical heat box. As for the inside of the heat boxes, there needed to be some kind of internal mount to hold the heat dome in an upright position. We used this old chemistry ring stand to plan out how that might work by screwing it into this piece of wood. Here's sort of how it would sit inside. And of course we had measured the heat dome before building the whole thing out, so we knew that the dimensions would be appropriate. We just hadn't figured out how the actual mounting fixture would work until this point. So then we took this idea and fabricated some ring stands using slices taken from an old piece of pipe. Then welded them to the front internal panel of the heat box. Lastly, the heat boxes needed to be mounted inside the terrarium underneath the shelves. Here's where the upper one would be placed. This mounting system needs to keep the heat box detachable so that we can remove it from the tank and replace the ceramic heat emitter as needed. So because the back is made of plywood at this height, the easiest thing to do would be for this one to attach to a bracket underneath the shelf that's attached to the plywood, and then basically slide the heat box back onto some rails. Here's what those rails ended up looking like. We also cut some corresponding holes in the heat box so that the rails would slide out through the front. And here's how the rails slide right through the heat box now. On the other hand, the lower heat box would need a different mounting mechanism. That's because the back of the tank is actually glass at this height. So we couldn't just stick a bracket on that glass panel like we did for the upper box. So instead of mounting to the back of the tank, this one actually needed to be mounted directly to the bottom of the shelf itself. We used some bolts here so that the heat box can be removed from the shelf with a wrench. Here's how those heat boxes sit underneath the shelves. And we also cut some extra panels to cover the backside of those heat boxes. Okay, these heat boxes need one last thing. Seriously, why did we have to make these so complicated? The top and bottom of each heat box needed to be sealed so Marmaduke couldn't get inside, but also needed to be breathable to allow heat to escape. So we decided to use metal window screen. The top screens also needed to be removable so that we could access the inside of the box to change the heat bulbs. That means they'd need a sturdy frame and some mechanism for popping the screen on and off. So we cut some strips of steel and placed them around the rim of the box to make a frame. Then welded the corners together. Then a piece of metal window screen was cut to size, and the edges of the frame were crimped over to hold the screen in place with some epoxy as well. This framed screen then attaches to the top of the box with some pins welded to the underside. And here's how that upper heat box looks as it's sitting on the bracket rails with its screen on top. And just like everything else, we had to make two of these, one for each box. The box on the left is the lower heat box, so it has some extra holes cut out of the screen frame to accommodate the mounting bolts. Phew, okay, metal fabrication is finally complete. Time to paint this sucker up. It was still too cold at this point to spray paint outside. As you may know, spray paint requires a minimum air temperature to apply and cure correctly. So we cordoned off a corner of the workshop using painter's cloth. Then we put some space heaters inside the little painting chamber to heat it up inside for a few hours prior to getting started. We put the frame in there too, so the metal itself would be the proper temperature for spray paint application. So it turns out that spray paint does not adhere well to aluminum and tends to flake off. So we actually needed to first apply this self-etching primer. It uses a chemical reaction to create tiny pores in the surface of the aluminum, which allows the spray paint to stick a lot better. Here's Marmaduke coming in to inspect our progress after a few hours of letting all the paint vapors dissipate. Then, of course, he wanted to go run outside in the sun, even though there was still some snow on the ground. So we took the frame outside to finish drying in the sun with him. You can see here that the primer has a sort of grayish color, and it creates like a fuzzy or soft texture on the aluminum. Again, these are those tiny little pores that allow the spray paint to bind much better. Next, all the additional parts needed to be primed. That includes the doors, brackets, heat sinks, plywood, handles, electrical boxes, and so forth. After thorough drying, this black satin paint could then be applied. All the pieces were then hung outside to dry, and after a few hours, moved back inside for the night. And here's Marmaduke coming in for another unannounced quality inspection. Here's what the respirator filters looked like after all that painting. You don't want that stuff to end up inside your lungs. After all the paint was dry, it was time to install the plexiglass panels. First, we applied some 100% silicone to the inside of the frame, and then put the plexiglass in place and used some wood supports and clamps to hold it down. When that first layer of silicone was dry, we were able to seal the edges of the plexiglass with even more silicone, both on the inside and the outside of each panel. We also plan to install a metal screen mesh at the bottom of this compartment with holes wide enough to let the majority of the light through, but not so wide that Marmaduke could get his hand stuck in there if he decided to climb across it like a jungle gym, which he has been known to do. This mesh comes in a roll, so it tends to want to roll back up when you try and flatten it. So we used some clamps and rocks and scraps of metal to keep it flat, while epoxying it to the inside of the frame. Lastly, we cut out some pieces of black coroplast to cover up the sides of this compartment. You can see that we've made the light brackets wide enough to put two light fixtures in side by side. With such a large tank volume, we really wanted to make sure that there was enough UVA and UVB rays getting inside, so we wanted space for two light fixtures. We also installed this electrical management panel on the side of the tank. There are 3 receptacles here, so that some of the components, such as the lights, can be set on different timers. All 3 of these boxes are connected such that there's just one common supply wire that goes to the wall outlet. This avoids the hassle of having a million things plugged directly into the wall. Whew, alright, well I think that's a good place to stop this video. If you've made it this far, thanks so much for watching. And please stay tuned for the next installment where I'll be showing you how I constructed the internal landscaping elements in part 2 of this video series. And since Marmaduke is really the star of the show here, let's end this video with some cute footage of him running around the garden after all the snow melted. Hey guys, thanks so much for watching. We'll see you on Marmaduke's next adventure.